Alright, our first problem is angle of elevation. So the angle of elevation from the bottom of the ski lift to the top is 33 degrees. If a skier rides 1,000 feet all the way up to the top, what is the vertical distance between the bottom and the top of the ski lift? Alright, so put our triangle down, our ski slope. Alright, our angle of elevation is 33 degrees, and the skier rides 1,000 feet. Alright, and then vertical distance, this is our x. Alright, so our equation is, because we want to find this, we'll go with sine. So sine of 33 equals, so opposite over hypotenuse, so x over 1,000. And then we plug that in to our calculator right here. So 33 sine, it's that number, so we'll just put an abbreviated version down here. So 0. What was it? 0.5446 dot dot dot. That's what we'll put. 446 equals x over 1,000. And then we just multiply it both sides by 1,000. Right, so we cancel that out. So we can go here and just multiply it by 1,000 here. Times 1, 0, 0, 0 equals, alright, so 544.64 feet. And that is the answer. Next problem is angle of depression. So the pilot of a traffic helicopter spots an accident at an angle of depression of 18 degrees. The helicopter's altitude is 11,560 feet. What is the horizontal distance from the helicopter to the accident? Alright, so we're going to draw our imaginary helicopter. And we can do our little dotted line here. So the angle of depression is 18. And the altitude is 11,560 feet. And our x is right here, the horizontal distance from the helicopter to the accident. So because it is a hypotenuse that we're trying to find, we have the opposite, we can just go with sine. So sine of 18 equals opposite over hypotenuse, so 1,560 feet over x. So sine 18, we can plug it into our calculator. So 18 sine is 0.309 dot 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 equals 11,560 over x. So we'll do some flipping here. We want to multiply both sides by x to get out the denominator. So we have 0.309 dot 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 x equals 11,560. And we can put both sides by 0.309 dot 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 and 0.309, and then get rid of that, so x equals, and then we can plug in a calculator by doing this 11,560 over, I'm just gonna copy and paste that to get 37,408.95 feet. And that's the answer for that one. So we're going to solve this one using Heron's formula. Lena is planting a garden in her yard. She uses 3 pieces of wood as the border. The pieces of wood have lengths of 4 feet, 6 feet, and 3 feet. What is the area of her garden rounded to the nearest hundred? So let's draw this out first. We know that it is a non-right triangle, because that is what the Heron formula is used for, finding the area of non-right triangles. So we do that and that. So we've got 6 feet, 4 feet, and 3 feet. Alright. Alright, so Heron's formula. Heron's formula is the area equals the square root of s times s minus a, s minus b, s minus c. Alright, so what is s? S essentially equal to a plus b plus c over 2. So in that case, s is equal to 4 plus 3 plus 6 over 2, which means that s is equal to, that is 7, 6, 13 over 2. I'm going to say that s is equal to 7.5, if you will. No, not 7.5, it's actually 6.5. Right, so now we plug it in. So a equals square root of 6.5 times 6.5. I am actually just going to put it over 2. 13 over 2 minus a, I'll just label them here, a, b, and c. That's not right. A, b, and c. So minus a is 4, so 8 over 2 times 13 over 2 minus 6 over 2 times 13 over 2 minus 12 over 2. Alright, so a equals square root of 6.5 times 5 over 2. 7 over 2 and 1 over 2. Alright, and then we can just plug these into a calculator. So 5 over 2, so 2.5 plus 3.5, no, not times, it's times, 2.5 times 3.5, times 1, times 0.5, times 6.5, equal to 28. We can just plug that in real quick. 28.4375. And then we can just take the square root of that in our calculator. Equal to 5.33. We'll run to the nearest hundredths place. Feet squared. And that is using the Heron's formula. Alright, so for this problem, we will be using the formula to solve the area of a non-right triangle. Alright, so for safety reasons, a footbridge is covered with triangular panels. Each panel is an isosceles triangle with each leg being 17 meters long and with the base angles of 70 degrees. Find the area of each panel. Alright, so let's draw our isosceles triangle. I'm actually an eraser. Don't need that. So, our isosceles triangle, it's got two equal legs and two equal angles. So, base angles are 70 degrees. Side legs are 17 meters. So, first we need this angle, which is 70 plus 7 equals 140. 180 minus 140 equals 40. So this angle right here is 40 degrees. Alright, now essentially the formula for the area of a non-right triangle is A equals 1/2 AB cosine, not cosine, sine, AB sine, 1 right cosine. Alright, so let's label our guys here. This is line A, line B, line C, angle A, angle B, angle C. Alright, so A equals 1/2 17, 17, and sine of 40. Alright, so the reason this formula works is essentially like finding the area of a triangle, which is 1/2 base times height. Uh, that height is actually equivalent to B sine C. So let's just fill this out. This is pretty straightforward. I need a calculator for it. So 17 times 17 is 289. We're just gonna stick this over here. So A equals 289 times sine 40 over 2. So A equals, and we're just gonna put 289 times 40 sine. We're just gonna plug that into 185 point 765 we'll and that over 2, and we can just plug that in right there, divided by 2, so 92.88 meters squared. And that is the area of each isosceles triangle. Okay, so next problem is law of sines, and the law of sines states that in a B and C triangle, that A over sine A equals B over sine B, which is equal to C over sine C. So we can move that over. So in this word problem, John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 33 degrees. This particular tree grows at an angle of 83 degrees with respect to the ground rather than a vertical 90. How tall is the tree? So here's our triangle with the tree. It's not really straight, but it's close. And here is our 83-degree angle from the ground. And from the ground to the top of the tree, that's 33 degrees. And this right here is 100 feet. Alright, so to get the law of sines, and use the law of sines in this, we need this, essentially the angle opposite to this one, which is pretty basic. We know that all angles equal 180 in a triangle, so it's just 83 plus 30 plus x equals 180. We subtract both 83 and 33 on both sides, minus 83, 33. We get 97, 64. Yes. Yes. So x equals 64, and I'm going to double check that in the calculator just to make sure. Yes, okay. So now that we have that, we know that we're trying to find this. This is our final x. So find sine of 33. We need to know that x over sine of 33 is equivalent to 100 over sine of 64. I'm just plugging it all from that. So move that up a little bit so I have room. So 33 sine x over 0.544 which is equivalent to 100. We'll just do that in the calculator right here. So 100 over 64 sine is equivalent to 11.26 and then I'll multiply both sides by 0.544. Same thing over here, 0.544, and we can just right here multiply it by this number right here. So that is 60. 60.60 feet. And that is the height of the tree. Alright, for this problem we will be using the law of cosine. So our word problem is to estimate the perimeter of a lake. Caleb starts at one end of the lake and walks 65 meters. He then turns and walks on a new path which is 120 degrees to the direction he was walking first, and walks 87 more meters until he arrives at the under end of the lake. Approximately, what is the perimeter of the lake? Yeah, so we can draw our triangular lake first. Let's do that better. Here's our, that's not very good either, our new triangle. So this is where he starts, 95 meters to 120 degrees, another 87 meters. Alright, so we need to use the law of cosines for this, which states that c squared equals a squared plus b squared minus 2ab cosine c. So we can label these there. So since we're trying to find initially this line right here to find the full perimeter, then that will be c, so that is x squared equals 87 squared plus 95 squared minus 2 times 87 times 95 times cosine of 120. And it's pretty much just plug it into your calculator. So x squared equals, I'll just do the full thing here, is 87 squared plus 95 squared. That's 9,025. Write that down, 9,025 minus, we just plug this in here, 2 times 87 times 95. Alright, 530 times the cosine of cosine of 120. Right, and then we can just multiply that by 20 cosine. Oh wait, no, 5 on. Enter that in wrong. 16530 times 120 cosine equals. Since that's a negative, we can cancel out this. So x squared equals 9025 minus negative 18,265. Since those are two negatives, we can cancel them out. So it's 9,025 plus 8,265. So we can just 1,265 plus 9,025. Yes, and we get 17,290. So x squared equals 17,290. And then we just find the square root of that, which is x equals, we can round here to the nearest hundredth, so 131.49. Alright, so that's our final side. Our hypotenuse is 131.49, but that's not the end because we need the perimeter, so we're going to add 95, 87, and 131.49. We can add them up here, so 9, 4 point, and that's 13, and that is that's 21, 3, and we can double check right here. 131.49 plus 95 plus 87. Yeah, so 313.49 meters is the perimeter.